Welcome to this explainer. Today, we're unpacking the revolutionary workflow of Aligner 4.0 and the absolutely incredible journey of shape memory aligners. We're going to track the entire process, from that very first consultation at the clinic all the way to a perfectly retained smile. We're completely stepping away from those clunky traditional analog methods and exploring a fully digital ecosystem that is quite literally changing the landscape of orthodontics.
Okay, let's dive into the foundational science first because it's fascinating. What makes this entire workflow possible is a huge breakthrough in material science called shape memory technology. You see, unlike traditional plastics like PETG or polyurethane that just permanently stretch out over time, this smart resin, specifically the TerraHAR's TC85 photopolymer, literally uses heat to remember its structural purpose. It's engineered with this dual network molecular architecture. Think of it like a microscopic rubber band that has a specific shape permanently locked into its memory. It can be temporarily deformed to slip comfortably over your teeth, but the second it's exposed to a specific thermal stimulus, it actively tries to spring back to its original programmed shape. To see how this all comes together, we are going to follow the exact life cycle of a single shape memory aligner through 4 precise clinical phases: consultation and digital design, fabrication and nitrogen curing, delivery and shape memory, and finally, long-term retention. So, kicking things off with Phase 1, consultation and digital design, building the AI-powered foundation. Our journey starts right in the clinic, and thankfully, we are completely eliminating the need for those gooey, gag-inducing physical impressions we all remember from when we were kids. Instead, practitioners are capturing the exact surface topography of the dental arches using high-fidelity intraoral scanners. And for more complex cases, things involving extractions or impacted teeth, they might actually integrate 3D X-rays or CBCT to get a complete picture. This purely digital data acquisition is incredibly fast, usually taking just 10 to 15 minutes, and it highly prioritizes both precision and clinical efficiency. Because we're moving the entire planning process into a digital ecosystem, clinicians can actually map out a confident, perfectly aligned smile way before a physical aligner even exists. You're basically looking at the before and the projected after, connected purely by data and AI. It is so cool to see that end goal designed with absolute precision from day one. It essentially boils down to a 3-step digital setup that replaces physical models entirely. First, the diagnostic scan grabs the 3D data. Second, that data gets fed into the SMA portal, which is this AI-powered software that automatically stages the orthodontic movements. And third, the shell engineering takes place in CAD software. This is a massive advantage. It means clinicians can engineer the exact variable thickness of the aligner shell right there on the screen. They can beef up the thickness where more force is needed and slim it down where comfort is the priority. All of this without storing a single physical plaster model. All right, moving right along to Phase 2, fabrication and nitrogen curing, printing the future of orthodontics. Now that we have our perfect digital design locked in, we transition from the consultation room into the lab. The lab workflow follows a very strict 3-step protocol. First up is direct 3D printing, which builds the aligner layer by layer using that TC85 photocurable resin. Now, unlike the old thermoforming process where you had to cut away excess plastic sheets and create just tons of waste, this additive method uses only the exact amount of resin needed. That vastly reduces carbon emissions, which is a huge win for modern clinical standards. Right after printing, we have residue cleaning, and finally, a highly specialized nitrogen polymerization process. Let's look a little closer at that second step. Normally, standard 3D printed resins are washed in these really harsh alcohol baths, but doing that to our smart resin would actually damage its unique shape memory properties. So instead, the aligners are placed in the TerraHAR's spinner, which relies on eco-friendly centrifugal force. It rapidly spins the aligners to strictly remove excess uncured material from the surface. It's cleaner, it's way faster, and it perfectly preserves the polymer's potential. But there is a hidden chemical threat lurking here, and it's called oxygen inhibition. Basically, if standard atmospheric oxygen touches the aligner during its final UV light curing phase, it reacts with the materials and terminates the polymer chains way too early. And if those chains terminate prematurely, you get an aligner that has a sticky, tacky surface, a cloudy haze, and potentially unreacted monomers that lower its biocompatibility. It's totally bad news. To prevent this failure, the TerraChair's Cur unit actually floods its chamber with 95% pure nitrogen. This totally displaces the oxygen, creating a vacuum that allows the UV light to trigger complete molecular cross-linking. This nitrogen environment is absolutely non-negotiable to make sure the final aligner is perfectly clear, totally safe, and structurally sound. Which brings us to Phase 3,
delivery, and shape memory, the magic of temperature activation. Okay, our liner is fully printed, cleaned, and perfectly cured. This brings us to what is arguably the most magical part of the clinical journey, delivery. The clinician takes this highly engineered, crystal clear piece of TC85 resin and prepares to hand it over to the patient. Now, remember, the aligner is engineered to fit the next stage of tooth movement, not where the teeth are currently sitting. So forcing it on cold could actually be pretty uncomfortable. And that is exactly where the shape memory aspect truly shines. Before placing it in the patient's mouth, the aligner gets a quick dunk in 60 to 70 degrees Celsius water. This pushes the polymer right past its glass transition temperature, which is essentially its magic melting point, where it enters this flexible, rubbery state, completely without losing its programmed shape. It instantly softens up, allowing for a totally painless, super comfortable initial seating over the teeth. Then, once it's inside the mouth, your body's natural temperature gradually cools and hardens it right back to its programmed shape memory state, and that initiates the gentle force needed to move the teeth. This is a total game changer for the patient experience compared to older technologies. Traditional PETG plastics start out strong, often painfully tight, right? But then they stretch out and lose their active orthodontic force in just 2 or 3 days. That leads to a loose fit and delayed treatment. Shape memory materials, on the other hand, constantly push back to their original printed shape. This provides a consistent, really light restorative force. The teeth move efficiently, without the pain, making that recommended 20-hour daily wear time totally achievable for the patient. And finally, Phase 4, long-term retention, securing the final position. Once the teeth are straight, the whole workflow abruptly shifts focus from active movement to permanent stability. The material you need for a retainer is functionally very different than an aligner, so the clinic actually shifts from the TC85 resin to a specialized TR07 resin. This new material has a higher flexural modulus, which is just a fancy way of saying it's significantly stiffer, to resist the teeth relapsing or shifting back. Importantly, its shape memory is deliberately limited. Retainers should just hold, not move. It also has lower water solubility, so it can really withstand the mechanical forces of teeth grinding and the chemical degradation from saliva over months and years of wear. What's truly incredible for the patient here is the speed, because this entire system, from that final intraoral scan to the CAD design, the direct printing, the centrifuging, and the nitrogen curing, is fully digital and can be done entirely in-house. Clinics can actually offer 1-day retention. A patient can literally receive their ultra-durable, custom-engineered final retainer on the exact same day they finish their very last active aligner stage. There's absolutely no waiting weeks for a lab to ship a thermoformed piece of plastic. So this brings us to the absolute bleeding edge of this technology. We've seen how direct 3D printing and shape memory polymers have created Aligner 4.0, but developers are already exploring 4D printing, where the fourth dimension is time. Think about it. If an aligner today can use simple body heat to activate one specific shape, what happens when we unlock a future where a single printed appliance responds to different wavelengths of light or varying temperatures to sequentially trigger multiple different tooth movements over months of wear? It's an unbelievable leap in bioengineering, leaving us to wonder just how smart these polymers will get as we step further into the fourth dimension of orthodontics. Thank you so much for joining me on this explainer. Keep asking questions and keep exploring.